This meeting is being recorded.
Okay, hello everyone. I hope you guys doing well and get more relaxed after 1 week of like politics things. So anyway, uh, today's session is one of the things that I said if we have time we go over that. So we try to do LP uh, programs. I mean, we are going to solve LP problems using a new software which is Lingo. I'm afraid if you learn Lingo, maybe you don't go back to Excel anymore because much more convenient and easier actually. But we do some experiment and you get some feelings about Lingo. Also, next class, I want to dedicate to your projects. So, especially for the people in the class, even if you haven't finished that, I want to get a feedback from you what's about your progress and the issues. And then I go over people over Zoom. So you guys can also discuss about your project, your concerns. And also we have final exam this year. I decided because we already reduced so much of weight for this course. You didn't have any quiz and no midterm because COVID time, and we don't want to load too much of pressure on you. Having said that, we have a final exam. Is a take home, and you might your answers even could be different. It depends, especially in the LP side. You might have different policies, and might you have different submission. All of them could be right. So, and it's individual exam. It's not a group exam. So each of you should submit one. Next couple of classes, I want to dedicate for your project and also sample problems of the exam. So I go over some sample problems and or maybe the problems that you want me to go further. If even we have extra time, like today, I do some extra software, or maybe I do more Tableau samples. Um, our, I mean, class attendance was arbitrary this semester. So from now, I mean, we almost ran out of teaching materials. I could teach more, but I think we covered my initial targets. So, and also we didn't have any break this semester. So anyway, any question from previous classes or uh, anything like material wise, assignments or final exam? So I cover some sample problems so you can understand what could be your final exam in the next sessions, like from Wednesday. For Wednesday, I want to mostly dedicate to your questions and your project because I want you guys to have good submissions. But if I have time, even next Wednesday, I go over some sample problems. Also, people over Zoom, you guys can ask your questions if there is any. Okay, if there is no question, please go week 13, download everything. So there is a Word document from, actually you already saw those problems. I picked the first 3 problems of your LP section or prescriptive analytics. There's an Excel file that has a solution in Excel, and there's 2 LG4 format. These are Lingo files, which I teach you how to download and install it. And we saw these are the solution in Lingo. So, anyways, please download them. I wait like a couple of minutes, then I got. Then after downloading, just go Google and say download Lingo. I wait a couple of minutes for you guys to just download the materials from Moodle. In the Excel solver, actually, sometimes you might be creative because you should make some relationship between your decision variables and constraint, and somehow could be challenging. So you need to make some tables and like for basically apply your creativity in the terms of like making connections between decision variables and constraints, and so some problems could be a little challenging. So by in Lingo, you just type whatever is in the problem, and just Lingo try to find the association by itself. So anyway, okay, please go to Google and just type download Lingo. I mean, the first link under lindo.com. So if you have a different link, it should be something on the Lindo website. Click on it. Okay, so go and download the latest version, 19. I already installed number 18, version 18. Maybe you can just, if you want to have same version with me, download 18. Otherwise, download the latest version. Download, install, just go next, and install the demo version. Demo version is for education purposes, but you can solve all of your problems. So in the demo version, number of decision variables and concerns are limited, but this is like industrial-based software, but for education purposes, so which number of variables and concerns are limited, you can easily use it. Just click on like, let me click this one, put your information. End user, student. I'm professor. I'm not a student anymore. Just submit. This is the link. It's a zip folder. You can unzip it or just. So I unzip the file. Yes. Next. 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 Install. Easy peasy. There's no challenges. I give you like 5 or 6 minutes for you guys to just finish installation. I exit because I already installed. So. Yeah. Please, for the next class, bring your questions. Or even if you didn't finish your project, I ask about your progress in your project and go one by one to see what comments I can give you. Just click demo. So if you're in the point that you already installed, let me go there. I'm teaching too many classes. So. On week 13, for example, click on Clerk Alumni. This time didn't ask me any question, but if you see any question, just click on demo about the license. So demo is for the education purposes. You have all the functionality except number of decision variables are limited. Yeah. I think a little bit more for all of you to be sure all of it or could install. Is the question over chat? Yes, one of your friends asked over Zoom. Yes, just select demo. Okay, hopefully, let me just go. Okay, now we go back to our first problem. One of our first problems was the Clark alumni who wanted to open, who had a restaurant probably and wanted to provide a meal. I give you like a few minutes to read the problem again. Then we go to the solution. You already had this problem. Okay. A Clark alumni owns a fast food restaurant named LP Clark. He plans to start a new family meal offer containing sandwiches and hash brown. He has to make a decision that how many sandwiches and hash browns to include in the meal offer. His objective is to design a meal with minimum cost. However, there are few requirements of the plan. So what are our decision variables? Yes, it's about, we should make a decision about number of sandwiches and hash browns. Okay. The cost of one sandwich is $5, hash brown is $1. So these are coefficient of decision variables. Because we want to minimize the cost, we know that the cost coefficients are $5 for sandwich and $1 for hash brown. The meal should contain at least 1,000 calories. So this is our constraint, right? So the calories should be greater or equal 1,000. The meal should contain at least 60 grams of protein. Second constraint. So protein content should be greater or equal to 60. And just looking at this table, we have the calorie coefficient of each decision variable. We have protein coefficient of each decision variable. The meat should not contain more than 80 grams of fat. So we have the fat coefficients. And it should be less or equal 80. The meat should contain at least 100 grams of carbs or carbohydrates. We have carbs coefficients. So don't go to that much of the question. Let's just formulate it in lingo and you would probably enjoy it. So if you click on that file, let me see if I can zoom it here. Unfortunately, I don't see any zoom. Options. This one. Anyway, I hope you have on your system so you can much easier see that. Look at the first line. Mean equal 5 times sandwich plus 1 times hash brown, right? Does it make sense? So it's just the way that you write it. Mean means is a minimization problem equal of decision variable multiplied to their cost coefficient. And you should put a semicolon. So it's the way that you formulate the objective function. If it's max equal coefficient of decision variable as semicolon. Look at the constraints. So our first constraint, the calorie should be at least 1,000 calories, greater or equal 1,000. And we have coefficient of calories, right? In the table, 300 times sandwich, 200 times hash brown. Look at the first constraint, 300 times sandwich plus 200 times hash brown, greater or equal 1,000 semicolon. Does it make sense? Because our first constraint is just make at least 1,000 calories. Second constraint is about protein, at least 60 protein, greater or equal 16. So sandwich times 20, because each sandwich has 20 grams of protein, and hash brown has 5, greater or equal 60. So third one, the meat should not contain more than 80 grams of fat. So it should be less or equal 80. And a sandwich has 20 grams of fat and hash brown 10. Look at the constraint. 2 times sandwich plus 10 times hash brown less or equal 80. And same for the carbs. On top of that, we know that hash brown and sandwiches should be greater or equal to 0. Doesn't make sense to have negative hash brown or sandwiches. Any questions so far? Do you see the formulation is much easier than Excel? So let me open the Excel file, which you have on your system. If you download from Moodle. This one is not too difficult. So you have a table, you have a total column, and this column just means these 2 times decision variable. So although this is an easy problem, even in Excel solver, but I think the formulation is difficult because you should find you have a constraint column, you have decision variable cells, and you should make those kind of connection. But look at Lingo, you just type as you think. There's no creativity in it. But how you solve it? Just click on this button, solve button. Do you see? There's a circle with a target, basically look like a target. Just click. Look at the answer. Objective value is 14. 2 sandwich for hash browns. You see the reduced cost. We didn't talk about dual price, but no worries, it's not a big deal. But we have a slack and surplus. So based on here, which constraints are binding, which one is not binding? So binding means your solution is in the intersection of the constraint. And you cannot change the constraint. Otherwise, your problem would change. On top of that, the constraint that shows your optimum solution or optimum points don't have any slack or surplus. So as you see, constraint 3 and 4 doesn't have any slack or surplus. Or here it just show with the row number 3 and 4. So 1, 2, 3, 4, 5, 6, 7. So number 3 is this constraint, protein. Line 4 is for fat. So it's the way that you read it. I know it's kind of different. So even the objective function is a row. So, and it assign slack or surplus for the objective function, but that's okay. I mean, it's a little, the interpretation is a little different, but first line 14 is for your objective function. Row 2 is your first constraint. Line 3 is line 3 is protein constraint, and line 4 is about fat. And your objective function is here. So you just need to how to find your answers and basically where are your constraints, where are your objective function. This software has more options in terms of sensitivity analysis, but since it's not our focus, I just want you guys to learn how to formulate it. So as you see, isn't it much more easier than Excel? You just type what is in your mind and you just solve it. In Excel, as you see, you should like put one place for the decision variables, then type the formula connecting your decision variable coefficient to decision variables and associate with the constraints. And even in the solver part, you still need to take care of like your constraint. It takes like several steps. Lingo, easy peasy. You just type what is in your mind. And solve it in your Excel too. So let's just solve the problem in Excel. Maybe let's see if we have get same answer. Yep. Is 14 sensitivity analysis. Anyway, no worries. I mean, in your final exam, you don't have to formulate in Excel. You can use Lingo. But you can check your answer in the Lingo with the Excel to see if you get something similar. If there's a discrepancy, maybe there's an issue somewhere. Yes. Yes, I tell you in the next problem. The next problem, we did integer programming. But you can Google it. So how to set up integer variables in the Lingo, or how to do binary variables, or some other problems. So anyway, any question about problem 1? Who has a different idea? Who think Excel solver is easier than Lingo? No one? Yeah, maybe for somebody working with Excel solver is easier. I don't know. But for your final exam, since it's take home, I recommend to check both, see if there's a discrepancy or not. Either one is fine. If Excel is too difficult, you can, at least in Lingo, you can type whatever in your mind and you get the answer. So it's better than no answer, actually. So people over Zoom, do you guys have questions? Okay, I don't see any question over Zoom. So let's look at the second problem. Let me just close it. Make or buy problem. I'll give you a couple of minutes, or just a few minutes to read that, then I'll go to the problem. Let me read the problem loudly. A company titled Worcester Balls produces 3 kinds of footballs: ball 1, ball 2, ball 3. Due to increase in demand, the production at own facility is not enough for this month. This month, a total of 3,000 bags of ball 1, 2,000 of bag 2, and 800 bags of ball 3 are required. As a manager, you have to make decision that how many units should be produced in-house and how many units in bags of balls can be outsourced to the other company in Boston. Objective is to minimize cost. Okay, so we have, so what is our objective functions? Sorry, what is our decision variables? Or what are our decision variables actually? That you either produce or outsource. So, and what is our objective function? Is a minimization problem, right? So if I write in lingo, I should type mean equal coefficient of cost times my decision variables. So also look at our constraint. At least 4,000 of footballs should be produced in-house. So basically, number of produced balls should be greater or equal 4,000. At max, 1,000 can be ordered from outside. So for outsourcing is less than equal 1,000. Let's open the Lingo file. In your folder, click on Ball Factory LG4. Okay, look at the objective function. Mean equal 52 times make ball 1 underline 1. So what does it mean? Ball 1 make 52. Plus 83 times make ball 2. 83 times ball 2. For ball 3, 130. So first are decision variables related to making the balls. Oh, sorry. Let me just close and open again. No. The next 3 decision variables are ball 1 buy ball 2, buy ball 3, right? And I put the coefficient of cost for buying. Any question about objective function here? Hopefully the logic makes sense. So I had 6 decision variables. I multiply the cost of either making or buying and put it in the objective function. Basically, I had 6 decision variables because for each type of 3 types of ball, make or buy, so 3 times 2, 6. So now you go to your friend's question about how to define basically integer. You put @ GIN, parentheses, your variable name. So it just says that those variables are integer. Or for binary variables, you can Google it to see how to. So it depends on your problem. So now let's look at the constraint. First of all, the first constraint actually was how many balls we want to produce. 3,000 of ball 1. So for ball 1, either you make or buy, right? So look at my first constraint. Make ball 1 plus buy ball 1 should be 3,000. Next constraint, 2,000 of ball 2. Make ball 2, buy ball 2 should be equal 2,000. And you know the way that you define the variables, it should start from a character, and you could have underline or numbers. So you don't put like some random or funny characters. Try to use this kind of character that I use, either underline or numerical, and start with a character, alphabetic alphabet. So, and 800, either you make or buy ball type 3. Now let's go to the next constraint. At least 4,000 balls should be produced. So 3 of our decision variables is about making or producing. So look at my first constraint: make ball 1, make ball 2, make ball 3 more than or equal 4,000. So this is our first policy. Second, please look, if there's a question, ask me, because there's a problem that I ask you to make your own objective function in Lingo. So at most or max, 1,000 should be ordered outside. Look at this line. Buy ball 1, buy ball 2, buy ball 3, less or equal 1,000. Then we have 2 constraints about hours of labor and budget for labor. So as you see, for ball type 1, it requires 2 hours of labor, ball 2 1 hour, 3 hours for ball 3. Is it the way that I put it here? So ball 1, 2 hours, ball 2 1 hour, ball 3, making ball 3, it requires 3 hours, and at most I have 10,000 hours. And the last constraint is about budget. So I know that for each type of ball, how much cost I should pay. $7 ball 1, $8 ball 2, and $7 ball 3, and at most $35,000. And look at the last constraint. So the cost coefficient times my decision variable less or equal 35,000. And also, number of balls shouldn't be negative. So all of them greater or equal 0. Any question about formulations? As you see, the only challenging part might be how to define an integer. The remaining is just you type how it's just you read it. So you type the problem as you read. So learning Lingo is just, it takes like 2 minutes, because it's like the way that you formulate is like very logical and mathematical formulations. And let's just solve it. So click on this button, solve button. This is the objective value. And you can do same in Excel, so I don't go in Excel at this time. So based on slack or surplus, you can understand what is your binding constraints, and which they don't have any slack or surplus. Look at here. In Lingo, we have two different, we have both slack and surplus, but in Excel, there is no surplus. All of them defined as a slack. So do you guys remember the differences between slack and surplus?
Equal, at least, and equal, less than or equal to, greater than or equal to.
Yes, when it's the constant is less or equal, we have slack. It just means your value from the constraint value. And when it's a greater or equal, it just says how much you're greater from the right-hand side. Yes. But in Excel, there is no differentiation. All of them has the name of slack. Any question? Okay, last problem, transportation problem. Look at this problem. First of all, we don't have, this is the easiest transportation problem. We don't have any limit over our links. So look at the processing plant capacity. So it can process 1,025,000 units. The supply is 975,000. So your processing plant capacity is more than your supply, right? So, and you have the miles from each supply to the processing plant. So formulate in Lingo. So I give you like 10 minutes to just formulate this problem. You can look at the Excel file that I provided for you. So you have the solution in the Excel. You have 10 minutes to formulate it. But first of all, this is how many decision variables I have here? So what is my decision? How much supply I should send in each link, right? So how many links I have? 9. So how many decision variables I have? 9, yes, because I'm deciding on how much supply I should send through each link. So yes, we have 9 decision variables. So when you want to type in Lingo, maybe you can say x1 to 1, x1 to 2, x1 to, oh, sorry, x1 to 4, x1 to 5, 1 to 6. So for the first 3 decision variables. For next 3, it could be x2 to 4, x2 to 5, x2 to 6 means from origin to destination. So I give you like 10 minutes to think about it, then I go to this. And I also send this answer solution to you later. Yes? Are you a question? Basically, one of our constraints is about processing plant. We want to send at least equal our processing plant, or you can, you know, you can define different ways, but I didn't put the a script for this problem, maybe you can say you want to send at least equal capacity or less or equal capacity. Both of them could be fine. If you say less or equal the capacity, you don't have any waste. Also, for the supply, maybe you can say, I want to say all of my supply, because at the end, your supply is less than capacity. You don't want to keep any extra supply because all of them are needed. Again, you might have different policies. The reason I said in your final exam, if there is such this problem, which I didn't put in a script, you have a lot more flexibility in terms of your policies. But if I provide a script, you might be limited in terms of the policy that you assign. So no worries if the way that I formulate this problem is a little different from me, because I just give a lot of flexibility in terms of how to put the supply constraint and capacity constraint. But in my point of view, which your point of view might be different, I want to send all of the supplies. So if I want to send all of the supply, x 1 to 4 plus 1 to 5 plus 1 to 6 should be equal 25,000. Sorry, 275,000. You still have errors? Okay, let's look at my solution. I know where I send you my solution later. Okay, let me close it. I think your objective function might be very similar to me. Minimization of miles times the decision variables. So for example, x14 is the miles from point 1 to 4, which is 21. So it's the reason there's 21 times x14. And same for all the decision variables. Look at how I define for the processing plant. I set the amount that they receive. For example, look at the first one. So it gets from 1 to 4, 2 to 4, 3 to 4. is how much the processing plant 4 receive. So I said the amount that you receive should less or equal 200,000, because if I send extra more than the capacity, I have some waste. You might have you might change it to greater than equal, and it could be fine too. So maybe you assume there is some waste, and so you change this one to greater or equal 200,000. So I just said there's a lot of flexibility. Same for second processing plant and third processing plant. The amount that they receive, I said less or equal their capacity. I think if you said greater than equal, might makes more sense, because in reality, there could be some waste. For processing plant, sorry, for the supplies, I said the amount that go out of point 1 from 4, 1 to 5, 1 to 6 should be equal my supply. Because I want to send all of my supply. Let's solve this one. Look at the answer. So can anyone tell me what does it mean? 0.2555000 E plus 0.8. What does it mean? Actually, it's kind of tricky. It just means that. Let me just type it here for you guys. It's just scientific format. It just means 0.255 0.000 times 10 raised to power of 8. So E08 means 10 raised to power of 8 is equal to 55 1 2 3 4 25,500,000. Because if you put 8 zeros, if you multiply 0.255 times 10 raised to power of 8, it would be equal this. If you have any more questions, you just Google. If you want to get further information, just Google calculator scientific format. And you can find some extra examples how to write in the scientific format. Any questions? Let's just play a little bit more. Instead of equal, I just say my supply should be less than these numbers. Could anyone guess what happens? If instead of saying my supply equal these three numbers, I should say less than those numbers.
I give you less than actually. So slack or shorter becomes 0 or 1.
The answer is 0. Because the minimum, when you said my supply is less than this, and it's a minimization, it doesn't send anything. Because you don't have to send all of your supply. You just say, at max, I want to send those amount of supply. So at max, like 275,000. So it's less than that, less or equal 275,000, it could be 0. Intuitively, if you don't send anything, you have the minimum cost. Yeah, I mean, I got here too. I mean, I put your constraint, I got 0. I mean, if you said equal, it send everything. Because equal means whatever you supply, the supply that you provide should be sent out. So although you have some flexibility, but if you put equal, if you instead of equal you put less, you lose the credit because your policy doesn't make sense. I mean, you don't get 0, but you lose a significant portion of your credit. Any questions? Okay, so if there is no question, that's for today. I think you will enjoy more playing with Lingo than Excel, because when you want to form in Excel, you need a lot of creativity. But in Lingo, you just type as you think, so much more easier and more intuitive. So okay, that's for today. I hope you enjoyed and have a great evening. Just